Good afternoon, good morning, good evening, everyone, and welcome to the online e-poster session 1 here at SNT 2025. I'm Sharif Ali, Head of Waveform Analysis Unit 1, Monitoring and Data Analysis Section IDC, and I have the pleasure, together with my colleague Ch1 Oliveira, the Hydroacoustic Officer in Software Application Section IDC, of serving as the conveners for this session. This is our first e-poster session of this week at SNT, and we are starting strong with 32 contributions covering a wide range of topics that highlight the diversity and depth of research in our community. I would like to extend a warm welcome to our presenters and thank everyone joining us today online for your interest and engagement. Over the course of this session, you will have the opportunity to explore the posters, interact with authors, and discuss their work.
Thank you, Sharif. So next we will stream the 1-minute lightning talks that we received from the presenters. So in total we received 19 out of the 32. And after we stream the 1-minute presentations, we will show the e-lightning slides of the presenters that didn't have the chance to send their videos on time, and give them the opportunity, if they are online, to present their lightning slides. And after that, we will open the floor for questions. Almost all the presenters are already online and they are keen to reply to your questions. So please feel free, and we also encourage you the most you can to send questions through the online chat.
We will now start with the lightning talks for online e-poster session 1.
I'm happy to introduce our work on the variability of ETAS parameters and earthquake forecasting in Africa. ETAS model helps estimate the clustering of seismicity, and variation in ETAS parameters indicate that earthquakes are driven by distinct mechanisms. Since the ETAS parameters are not transferable across tectonic settings, so region-specific calibration is essential. However, in Africa, no such estimate exists. So in this study, we investigate the variability of ETAS parameters across the continents. We examine the potential correlation of those parameters with crustal properties, and we also use them to infer the probability of large earthquake across the continent. So if you are interested in all these, please visit our poster, which is P12. 142.
How deep should we go to improve detectability in the presence of human-made noise? We tested this at Glasgow's 5-sensor vertical array using 2 complementary approaches. On the left, we examine background noise with power spectral densities. Above 1 Hz, deeper sensors are consistently quieter. We also show how events are captured at the array. The top right is the same event across all instruments. For about 300 events, we computed signal-to-noise ratios across frequency bands. And we noticed that for local to regional distances, here up to about 1,000 kilometers, deeper sensors show clear gains, but offer little to no benefit at low frequencies and therefore for teleseismic ranges. So if you want to improve local and regional detectability, consider going deeper than a few tens of meters. Check out the poster for more details.
Hello, my name is Blaine Bockel, and I am a seismologist at the Idaho National Laboratory. In my e-poster, I will be showing a brief overview of the Idaho National Laboratory Seismic Network. This will cover a brief history of the network, and its current status. I will also show an analysis of a possible boloid which was measured by both broadband seismometers as well as a single infrasound sensor. In addition, I will also introduce the Idaho National Laboratory National Security Test Range and show data collected from a recent 5,000-pound detonation.
Hello everyone, I am Abraham Arimuko as a seismologist in Indonesian Agency for Meteorology, Climatology and Geophysics, and I already have a master's degree from National Central University. This occasion, I would like to introduce our research about the geodynamic of the Sulawesi Island and its structure based on the P-wave, delay time, ray tracing, and shear wave splitting phenomena. And if all of you interest to know about that, you can come to our poster session and take a look at our poster. And in general, we would like to discuss about the geodynamic of Sulawesi due to the complexity of tectonic setting.
Everyone, my name is Delia Bello from the National Seismological Service at Ch1. Our poster is about the seismicity and stress field in the Valley of Mexico. I am going to tell you why this is important. Mexico City is highly vulnerable to local earthquakes, and understanding their mechanism is crucial for seismic hazard assessment. And what we did about it was to analyze 24 earthquakes from 2010 to 2024, grouped in 5 seismic families and performing moment tensor inversion with the ISOLA software, under strict magnitude, station coverage, and signal-to-noise criteria. The most important result of our work is that we found a predominance of normal faulting with a strike-slip variability and even evidence of unmapped structure in central Mexico City. If you want to find out more, please come over for a chat in front of our poster. Talk to you. Thank you.
Hello everyone, my name is Clyde Joshi from Institute of Geoscience, Polytechnic University of Tirana. I will present our poster with title Spatial Temporal Distribution of p-value in Albania and its surrounding over the last decade, with my co-authors, Professor Edmond Dushi, Damiano Koce, and Cristina Natrago. This poster presents a spatial temporal analysis of the Gutenberg-Richter p-value. The ZMAP software was utilized to map the spatial variability of Gutenberg-Richter parameters on the cluster seismic catalog, which was produced by the Institute of Geoscience. The most significant outcome of our study is that the low p-value corresponds to known seismogenic zones and areas where major earthquakes have occurred. If you want to find out more, please come over for a chat in front of our poster. Here we have the p-value map. Thank you. Bye.
Hello everyone, my name is Kenton Hummel, and on behalf of myself and co-authors here at Idaho National Laboratory, I encourage you to come see our poster regarding seismoacoustic monitoring of power processing equipment. Our work focuses on the capabilities of this type of monitoring for safeguarding power processing. This type of monitoring avoids challenges such as the high temperatures and radiation levels found within a hot cell that's typically used for this process, as well as limited access to the equipment. Here's an example of our data. This is a spectrogram showing frequency over time for both seismic and acoustic modalities. These measured signals show chopping of spent fuel, which is used in the initial step of power processing. Here are cassettes of fuel monitored that show differences across modalities, as well as even differences within each modality itself. So if you're curious regarding what these signals mean, why there are differences, or what else this monitoring can discover, please stop by.
Hello everyone, I am Jonad Muchai, and today I will take you on a short journey along one of the most fascinating tectonic structures in northern Albania, the Shkodër Bay Fault Zone. It stretches northeast, combining transverse thrust and oblique faults, shaping the terrain for millions of years. Formed during the Alpine cycle and reactivated in the Pliocene Quaternary, it has carved deep structures such as from Sishepugi Graben and the Baranzuri Depression. We analyzed geological and seismological data to understand its tectonic role and seismic potential. The most important result of our work is that although recent active seismicity has been mostly low energy, the structural settings indicate a significant potential for future strong earthquakes. Studying it is the key to understand seismic hazard in northern Albania. If you want to find more, please contact my email. Thank you very much.
Hello everybody. The title of this presentation is Seismicity and Morphometric Studies in North Sudan by Khaled Yassin Ibrahim. Our poster is about seismic study and morphometric parameters in North Sudan. Many earthquakes were reported in this area. The increase of seismic activity in recent years and the location of the region between Aswan High Dam in the north and Marawi Dam in the south motivated the researcher to achieve seismicity and morphometric studies in the area. This research was performed using many types of data. Various processes and calculations were applied to perform this study. The final results revealed that the earthquakes in this area are of shallow type, and the area distribution of seismicity illustrates that most of the events are concentrated in the area of moderate and high normalized difference water index and drainage density. The below figures illustrated the final results. If you want to find out more, I invite you to visit my poster. Thank you.
Hi, my name is Mahmoud Salam. I'm working at the National Research Institute of Astronomy and Geophysics. My poster is titled Real-Time Earthquake Detection Using Euro 8 and Program Analysis. My poster is about using deep learning to automate detection and classification of earthquakes. This method dramatically speed up the seismic analysis. This large scale of seismic data now exceeds the human ability for manual analyze. So we develop a complete pipeline transforming raw seismic waveform into spectrogram. Then we trained yellow version 8 model on this large annotated dataset, not only to detect earthquakes, but also to classify earthquake into local or regional earthquake. Even we can identify more classes like the B phases or S phases or different type of other type of earthquakes. This model have a very good performance. It's up to 96% for local identification and 91% for regional earthquake identification, with minimum confusion between the two types. For questions or ideas, please find us at the poster. Thank you.
Hello everyone, my name is Antoine Verdier, and I want to talk to you today about three-dimensional numerical simulation of infrasound propagation in the shadow zone. So this problem is present in various events and studies where the source geometry or the heterogeneous propagation medium can create this zone. On the left scheme is represented the source geometry problem. Here the source is a fall of a meteorite. The angle creates a limiting ray here, where under the ray there is no geometrical propagation. However, due to the diffraction effect, acoustic waves can propagate like the creeping wave on the ground. On the right scheme, this is the propagation medium that creates the shadow zone. The waveguide here is focusing rays on a single zone called caustic, and from this caustic can propagate in the shadow zone a diffracted wave. So operational simulation methods such as ray tracing cannot account for the diffraction effect, which excludes propagating in the shadow zone. So we have to find another numerical method which describes all the physical effects needed, but at the same time is not computational costly to be used in operational. Thanks for listening.
Hello everyone, I'm Colin Pennington. I will talk about our work on an empirical evaluation of the International Monitoring System's detection capability. The goal of this was to estimate the detection capability of the currently deployed seismic components of the International Monitoring System. To accomplish this, we utilize a global catalog of earthquakes to estimate if a seismic station detected an event or not. Why earthquakes? Well, the catalog provides useful information on how analysts behave and how they utilize stations. Using over 2.7 million earthquakes, we estimate the detection capability of each station. We then combine these to make one for the entire globe, with a requirement of at least 3 stations detecting an event. We show the results here. From this analysis, we find that even the incomplete network is able to detect magnitudes 4 and above around the world, except for some select places in the southern Atlantic. The auxiliary provides some benefit, but not as much as one might expect, and this is primarily due to how it's used and not its actual performance. If you want to learn more, please visit my virtual e-poster.
Good day, everyone. My name is Hubra Zafrakut, and I am a researcher from the Institute and Observatory of Geophysics in Antananarivo. And this work is about distinguishing earthquakes from anthropogenic events in Madagascar. So why do we need to do that? As we know, seismic sensors record both anthropogenic and natural earthquakes. Therefore, without an effective way to disseminate this event, our catalog could be contaminated, and that could bias our seismic hazard assessment. So this study uses the convolutional network to classify those events. And as a data, we use seismic events from 1988 to 2023 in the central part of Madagascar. And for the result, I invite you to join my poster. Thank you.
Hello everyone. My poster is about comprehensive seismic study of North Sulawesi in Indonesia. I will discuss about p-value, seed value, and also earthquake recovery time. The aim of my research is to explore seismic activity in North Sulawesi, Indonesia for earthquake and tsunami risk mitigation. I try to calculate p-value, seed value, and also identify earthquake recovery time with USGS catalog data and analyze with software of CMIL version 7. The main finding of my research is we will talk about p-value, seed value, and also recovery time. And the research has implication that findings aid in identifying high risk zones for seismic risk mitigation. If you want to know more about my research, we can talk together and we can discuss in advance, so you can come to my poster. Thank you.
What we're asking here is which factors determine whether a seismic station detects an event or misses it. Is it only the source, or can we also identify station-related factors that influence its performance? We start with a baseline detection model for 4 IMS stations we tested using event magnitude, distance, and depth. And then we introduced the heat score, which compares observed and predicted probabilities in global cells. On the right panel, you see the heat score. So where the station performs better than expected, these are red cells, and worse than expected are in blue cells. Adding this regional feature gives a slight but consistent improvement for all 4 IMS stations we tested. We also find that local time at the station matters, as detection percentage drops during daytime, likely due to higher cultural noise. So together we aim to move toward more realistic detection models that capture source, path, and station effects and use them for strategic network evaluation.
To enable rapid evaluation of the imaging potential of resonance seismometry for RES and active seismic surveys or ACT data acquired during an on-site inspection, semi-automated workflows have been developed. Both workflows were evaluated in an OSI 2023 field test experiment and also in an OSI 2024 build-up exercise in Hungary 2024. The ACT workflow follows a minimalistic processing approach, leading to a generation of a brood stack, and we can see first the results of the refraction tomography here shown on the left, and then we can see the results of reflection seismic processing workflow, where the tunnel diffractions are indicated with the red arrows, the P-way tunnel diffractions, and the blue arrows, S-way tunnel diffractions. Also, we can see that on the autocorrelation results of the resonance seismometry data. We can see the same signature of tunnels in terms of both P and S wave tunnel deflections. The second data set where the workflows were evaluated was from Hungary PUE 2024, and we can see the results of the ACT diffraction. We can see here a sharp change at the location where the tunnels are expected to be. This eastern portion is an anomaly and should be ignored. If we look at now the reflection seismic processing result beyond microgrid section, we can see a break in continuity where the black arrow is pointing. However, we must note that the site is quite complex, and it is the mining infrastructure, the tunnels are at different depths. If we look at the autocorrelation results obtained using resonance seismometry data, you can see some signature of the geological structures, but it is very difficult to interpret the signature of the tunnels.
Analysis of infrasound generated by the meteoroid explosion over Japan on November 29, 2020. Our work is about the location of the bolide over Japan estimated using infrasound data from the International Monitoring System, IMS. We used the method called progressive multi-channel correlation to estimate signal attributes and locate this bolide. We located the meteoroid explosion near Shingu in Wakayama Prefecture, Japan. This location is consistent with sightings, and it's very similar to what was estimated by the Center for Near-Earth Object Studies, CNEOS. CNEOS also estimated the yield of this explosion in 1 kilotons of TNT, which shows that IMS network is sensitive enough to detect small yield events.
An earthquake focal mechanism describes faulting kinematics and geometry. For weak seismic events, an ambiguity in focal mechanism determination is often related to a lack of close seismic citation. This problem can be partly solved using distributed acoustic sensing, a rapidly developing technology allowing us to record seismic events with optic fibers. In our poster, we review different methods of focal mechanism estimating using distributed acoustic sensing data. We have selected the most preferred method from our point of view, and we formulate some issues of its practical application, which were not discussed in the original paper. And we also describe our first steps to answer these issues. To find out more, please see our poster.
I'm Josh Carmichael. My co-authors are Brent Delbridge and Richard Alfaro Diaz, and our poster is Signals of Explosions and Earthquakes, Case Studies with Spotlight Detectors. Our poster shows that we can explicitly measure the rate that correlators fail to detect repeating explosions, given that earthquake signals interfere with the signals of these explosions. We detail this in 3 steps. First, we build a semi-empirical data set of interfering signals. In detail, we amplitude scale signals of explosions to make them mimic smaller explosions and deliberately add them back into data at times a beamed F detector triggers against earthquakes. Second, we process this compound data stream with a correlator that uses a template sourced by a small explosion. Third, we bin detection rates by yield. We then compare these true positive rates against baseline detection rates in which our correlator processes just noisy explosion signals. Come by to see the details and our numerical values from this experiment and to discuss implications for explosion monitoring.
Thank you for the presentations and for sending the videos. We will now project the enlightening posters of the colleagues that didn't have the chance to send the videos, and we go one by one and give 1 minute for the presenters in case they are here and they want to make their presentations. In the meantime, I would like to remind you that you can send questions in the chat that is on the right bottom the platform where you are streaming these presentations. So yeah, we'll move now for the posters. So if Kanao is online and wants to present the lightning slide, we have 1 minute. So we will move to the next lightning slide. So the next slide is on. Next presentation. So we move to the next presentation. So if you are online and you see your e-poster, please go ahead and if you want and present your poster.
Hello all. My name is Andrea Dar with Sandia National Laboratories. Our work involves quantifying the uncertainty of a joint time variable moment tensor inversion framework applied to both traditional seismic and gradiometer data. We apply this algorithm to 3 synthetic data cases, each with 100 inversion realizations generated using the Carhoon and Loew theorem for individual inversions and joint inversions of both the seismic and gradiometer data. We examine the uncertainty in the recovered source mechanism and yield for each of these cases, and the example to the right shows the yield estimates from synthetic data for a single array for an individual seismic inversion, an individual gradiometer inversion, and a joint seismic gradiometer inversion, showing that a joint inversion formulation can significantly improve inversion results for source characterization. If you're interested in learning more about our work, please visit our poster.
Thank you, Andrea. So we are receiving here some comments online. It's just a reminder. Now we are going through the e-posters of the presenters that didn't have the chance to send us the videos. So if we are quiet, that means that we are expecting the presenters, if they are online, to present their lightning slides. So go to the next one.
Already presented.
Yeah, we'll move to the next one.
Again.
So we move to another e-poster, so we still have 4.
Yes.
And so we believe that we went through all the e-lightning slides, and we will open now the floor for questions. Sharif already took note of some of the questions that we received here online. So we ask the presenters to unmute themselves if the question is for them and reply the questions. And by the end, also, if the presenters wants to make some questions, please feel free to ask.
So thank you for sending the question into the chat. So now the first question for poster 3.5758. So Plain Bocholt. So the question is, to get the track of the bolide, did you use straight rays for your model? How much does that affect the results?
Sorry, this is Blaine Buckle. And can you please repeat the question? Did I use the rays?
The track of the bolide. To get the track of the bolide, did you use straight rays for your model? How much does that affect the result?
Yes, for preliminary results, I just use straight rays to calculate the arrival times of each. I haven't had the time to get into using any sort of wave propagation through the atmosphere, so I don't know right now what the effects have with using a straight ray versus some sort of wave propagation travel time.
Thank you.
Thank you for answering the question. I think if the question is, if the answer is fine, so we can move to the second one.
So we have a question for 3.5444 for Andrea. Could your methods be used to identify progression from an explosion-like source to tectonic-like source triggered by the explosion?
Yes, it could. So it's a time variable moment tensor inversion. So it solves for a moment tensor representation through time. So that can be an explosion followed by slip on pre-existing joints near the source, or any combination.
Thank you. With more questions, Sherry, if you wanna.
Yeah. So for B3.5442, Mr. Mahmoud Salam. So we have two questions. Yeah. So how might this approach be tailored to detect other waveform types of interest to CTPTO, such as hydroacoustic and infrasound signals? Should I repeat?
No, I can hear. Can you hear me?
Yes.
Okay. To identify or to add more classes to this system, just by preparing a suitable data set that include and annotated with this specific new classes, we can retrain the model to be able to identify any type of signals. It's like mimicking the human ability to identify. It's like computer vision.
Okay.
So we have a similar question for P4.1206, Dorian Goldries. So did you think about extending your analysis to infrasound and hydro? And if yes, what do you foresee that will be the challenge?
Hi. Yeah, that's a good question. I mean, I haven't thought about infrasound and hydroacoustic. Well, I'm not sure what would be the challenge there, but that's an interesting path to explore.
Okay, thank you, Dorian.
Yeah. Another question to Mahmoud Salam, P3.54442. So how could integrating this technology reducing the analyst workload while maintaining a high detection capability?
By implementing like this AI technologies, we can reduce the amount of work that can be done by the human. Just we apply this AI technology to able to detect and identify different type of phases and reduce these peaks and events as a part of the routine pipeline.
So thank you. We have a question for Diogo Albuquerque. So P5.1830 is what do you imagine as the next steps for your research? For example, the use of ray tracing, estimating the yield.
Hello, guys. I don't know yet because I'm still learning how to work with the infrasound data. I started this. I just started this research more like an exercise to understand how to use the software and how to locate bolide, especially for the Brazilian area. So I used the Japan bolide to test if my analysis was correct. So I just want to try the same analysis for bolide occurring close to the Brazilian territory. I don't know how to implement another package or software to analyze better or to locate better the bolides, but I'm still working on it.
Thank you, Diogo.
So one question to 4.1221, Mr. Colin Pennington. So what are the advantages of using the ICC bulletin in evaluating IMS detection capability?
The benefit is that the ISC contains catalogs from all around the world that uses networks that are not part of the IMS. So much smaller networks that are read from regional operators. So it contains a more complete bulletin down to smaller magnitudes for all parts of the world.
We received a request from a presenter that didn't arrive on time and would like to present the lightning slide. So we will do it now.
We will do it in a second. And she's on.
Okay, the slide is on. Please go ahead.
Hello, everyone. Today, I'm going to present our new 3D dynamic earthquake rupture simulation for the potential main Marmara Fault earthquake, which is also called Istanbul earthquake. In our model, we not only consider interseismic stress accumulation due to plate motion, but also calculate stress perturbations caused by 1912 Ganos and 1999 Izmit earthquakes, both of which had a magnitude of 7.4, and we present changes in maximum sleep on the fault and extended PGV distributions. We also discuss the effect of the 23 April 2025 magnitude 6.2 Marmara Sea earthquake. If you are interested in the Istanbul earthquake or 3D dynamic earthquake rupture simulations, please come and see my poster at P12093. Thank you.
Thank you for the presentation. We have one more question for 3.5758. is thanks for your previous answers about using straight rays. Would the cost-benefit ratio be worth the effort of going to a complex propagation model, given that the model may not be known with high accuracy?
That's a good question, and I don't know. I have some wave propagation software that can use a more complex model. But like I said, I just don't know. It's something I think worth exploring, but I just haven't had. This was kind of a little side project that occurred at our seismic network, so I kind of work on it when I have free time. So yes, I think it's something that should be looked at, and I plan to do it. I just haven't done it yet.
Thank you. Sharif, you have...
Checking. Do we have anything?
So we are waiting to see if we receive more questions online. We have a question for Anthony Verdier, but my understanding is that Anthony is not here. So, we also have a question for Alena, but I think that Alena is also not online. So I encourage the participants then to approach the presenters through their emails. So I'd like to open the floor for the presenters that are online here with us. So do you have any questions for the colleagues that also presented, or do you have any comments, anything that you would like to share in more detail about your presentation?
I had a question. This is Josh Carmichael from Los Alamos. If people can
Hi,
hear
Josh.
me. Hi. There was Antoine. I'm probably going to mispronounce this name. Antoine Verdier here, or no? I'm not seeing their name. I had a question about their creeping wave, but if they're absent, then I guess I'll send them an email instead.
Yeah, I encourage you to do that because I don't see the presenter here. We have one more presenter that arrived late and would like to present the lightning slide. So we will give the floor to the presenter.
Okay, thank you for the opportunity. My name is Benjamin Herianto Santo. I'm from Indonesian Meteorological Agency of BMKG. Our poster is about in situ calibration of the CTBTO seismic station in Lembang, West Java, using a Python GUI-based software implementing the Gabrielson method for broadband seismometer, like a stage 2 sensitivity estimation against a reference seismometer like a Trillium 120. I'm going to tell you why the in situ calibration and CTBTO BMP station ensuring accuracy, like ISO IC 70025 traceability to the SI unit and reliability seismic data without removing instrument is important and fascinating. And what we did about the calibration was deploy a Trillium 120 calibrate in the NMI, National Meteorology Institute, alongside an STS2 as Lembang station, and then apply the Gabrielson method with the bandpass filter, segmentation, well, spectra, and coherence estimation, sensitivity to analyze and understand it. The most important result of our work is that stage 2 sensitivity divide less than plus minus 5% from the sensitivity from the math factory is 1004 per meter per second dataset with uncertainty analysis value, confirming reliability, the efficient traceability, and situ calibration. If you want to find out more, come over for a chat in front of our poster, and we will be glad to explain the Gabrielson implementation and the application for CTBT of BMKG seismic monitoring traceability. Thank you.
Thank you, Benjamin. So now we received one more question for Mr. Protek, 3.3527. How would you develop the data processing workflows further?
Well, I think further you can do only as much as possible with machine learning. In the end, there is simply no chance that everything could be fully automated. I think that the process can be improved a little bit with additional machine learning implementation, especially with the first rival picking, because this is a common problem also in global seismology, not just in near surface seismics. But I think still the most tedious part would be the first rival picking, which could be optimized definitely with further machine learning. And then in the end, additional processes that would work on the wave field separation. So to separate the diffracted versus the reflected and refracted wave fields to understand more the location of the actual subsurface anomalies.
Thank you, Bojan. We have one question for 1.2681. Not sure if Dazimai from Mongolia is here. So I don't think so. So we have one question here that doesn't mention the poster, but I believe that is for Dorian. Is how do you choose the right time to superimpose the noise equation?
So I assume we're talking about the poster for the different depth instruments. So what I did is I followed the IDC operational manual. So eventually it took 60 seconds with some buffer of a few seconds before the event starts. So that would be the way that I chose the noise portion, and similar goes for the signal portion of the waveform. So I took a few seconds. I think it's about 6 seconds or maybe less with a moving average window. So just following the IDC operational manual, trying to mimic the processing style.
Okay, thank you.
So I have one more question to P3.1694. So Mr. Benjamin. So
yeah.
How does the Python-based software improve calibration workflow and reduce operational downtime for IMS station?
Yeah, thank you for the question. Yeah, we deploy the Python with library like OpSpy, and the calculation method is first we must make sure that the coherence is value is up 0.8, and under if the coherence value is good, we the next step is we make some range of filtering, and after that, we calculate the sensitivity by the ratio from the amplitude for the reference seismometer and then amplitude for the seismometer under test, and we get the sensitivity. And in the report, we make some the mid-band sensitivity is we adjust to the REST file in the zip file and the XML file, and then bring up to the seismologist to update the instrument response from all sides after the calibration, like that. Thank you.
Thank you, Benjamin. We have one question for Kenton Umel. Are there other types of operations in the nuclear industry that will benefit from seismoacoustic monitoring?
Yes, absolutely. I don't know if I can extend on that more, but I mean, there's, yeah, this is just kind of the starting of some of the work that we're doing, but a lot of different processes can definitely benefit from this work.
Thank you.
So another question we have to Mr. Dorian Gurles. So 4.1206. Have you done any time of year, e.g. seasonal analysis? Do you think that could also help with network optimization?
Yes, I mean, I haven't done so. I started to. So I guess this question follows up on the daily hours of operation that I noticed that during daytime, the detection capabilities of several stations goes down. I have some thoughts about looking at seasonal variability, and I started to doing that. So I assume it can influence the detection capabilities of a few stations. So that's what I'm looking forward to do.
Thank you. We have one question here online, just 1 second. Is for 2.1 674. 674. So it's for Josh. Yeah, so I just made the question.
I'm here.
So the question is, can an earthquake or aftershock sequence mask an explosion?
Yes. First, let's verify everyone can hear me.
Yes. Yes. Yes.
Okay, thank you. I had to use my phone for audio, so if there's a slight delay, I apologize. So, yeah, quantitatively, what we found was that if explosions and earthquakes are of comparable magnitudes or equivalent yields, then that the waveforms sourced by the earthquake, if they interfere with waveforms sourced by the explosion, then even very sensitive waveform correlation detectors show a significantly reduced capability to trigger against the waveform sourced by the explosions. So quantitatively, if there is an explosion that's a very small explosion, that's about 1.7 tons of TNT equivalent, a correlation detector operating in just seismic noise will detect it almost always, about 97% of the time. But if it superimposes with earthquakes, then on average, that detection rate drops to about 37%.
Thank you, Josh. Do we have more questions? So more questions coming online.
One more question to Dorian. How did you take into consideration that many LED events don't go into the REB? Any comment?
No, I did not take that into consideration. as a first step, since these are preliminary results, I chose the LEB, and to mark the event as detected or not detected, I simply go to each of the stations and look for the phase that is time defining. So I did not consider any following processing of the REB.
Thank you.
So you have okay. So I think that we went through all the online questions, and we are also reaching the. We still have 15 minutes. So do you have any question? I'm talking now for the panelists that are online. Comments after this round of questions? Something that wants to share with the colleagues here and the ones online?
We have one more question, but we don't know for whom. So if you can clarify, the question is, how do you choose the right time to superimpose the noise equation?
I think that was the for Dorian.
For Dorian,
yes,
yeah.
the one that you asked before.
I ignore it.
So if we have no more questions, we can proceed and close the session. So from my side, and also on behalf of my colleagues, I want to say thank you to all the presenters. We have here presenters from all around the world at different time zones. So big thank you for your effort to be here today, also for preparing the presentations, for sending the videos, and for being available to reply to the questions. Also want to encourage all the participants that have further questions, or now that they will have more time to go through the e-posters, feel free to contact the authors. So this is what we want to see. To see interactions between the participants and learn from each other. So I will pass now to Sharif, and hope to see you soon in one of the CTVTO events.
So I just will extend the warm thank you very much for your contribution today and for your engagement. It was really great to have you today in our first e-poster session. And your questions, your answers, your presentations were greatly appreciated. Yeah. So thank you again, and we will end our session here. Yeah. Thank you so much.
Yeah. Thanks, everyone.
Thank you, guys. Bye-bye.
Thank you.
Thank
Bye.
you. Thank you.
Bye-bye.
Bye.
Bye-bye.